What is going on, guys, and welcome back to another one of the videos. It has been quite a while since I've posted, but now I'm back. We're back, so let's go ahead and do it. Just a quick note, this is the third time that I'm recording this right now because first time I did not have the microphone on, then second time I did have the microphone on, and then but it was not turned on, and then this time I actually figured out it's... Anyway, so let's just go ahead and do this, guys. So today's problem looks like this. We have two triangles with the same length, just basically here, which is just drawn out, right? And you have a point P, the intersection point. And our question is, what height is this point P at? Okay, that's our question. This height H is our question. Good. How do we do this? How would we approach this? Let's just have a look. So you might say, well, this is impossible because you don't have the length here, you don't have an angle here, you don't have anything except for this 90-degree angle. But as you guys know, you need three informations to define a right angle triangle. So that is correct. We don't have a lot, but as you know, math is very intelligent, and math can figure these types of things out. And so I thought to myself, when doing this, is that, well, this has to be possible. And what I thought, one of my first things was what I'm not going to say right now because that would already spoil the solution. But what I just thought is, okay, whenever I want to find a point that is not clearly calculatable. Like, you could just say, okay, I'm gonna draw another line there, but then, dude, you're splitting this unknown length into some times the length and then another times the length. That does not make sense, right? So I actually went ahead and drew a system of coordinates, of course x and y, right? And what I did is I just drew this construction right in here. So I just said, okay, this, this. That's what I did, right? Good. And now, as you guys can tell, it's a little bit easier. We have a point P right here. Okay, and now, how do we continue now? Well, we don't have this. We don't have this. All we have is this 5 and this 8. How do we do this? Well, a thing that came to my mind when solving this was that, is it not possible to take any x and still make it so that this applies? And the answer is yes, that is indeed true. But how is it true? And can we maybe prove that it is true? Let's have a look at this. All right, so this is, I'm trying to keep it as simple as possible as always, right? So you have these two triangles. This is one, this is another. This is just together, right? Okay, and what actually defines this point P, right? In a system of coordinates, what actually defines a point? Defines a point. A point is when two lines intersect at a single point, right? That's the point that we're basically searching for, right? The intersection point of two lines. How many do these two lines have? Exactly one. Who would have guessed? Anyways, so we have one intersection point that is somewhere here. Now, as I said, two lines. What is that implying? It's actually implying that it does not matter how long this line or this line is, and neither does it imply how long this line is. Now, that's a bit of an interesting thought, because if I change this to 7, surely it matters. But the truth is that it, of course it does. Yes, if you change this to 7, the point of course goes down. But what defines a line, right? Let's just first think about that. What actually is defining a line? Now, a line is defined by 2 points, right? You have a linear equation is defined by 2 points. Defined by 2 points. Okay? 1, 2. That's all you need. And if you think about this, don't we already have these 2 points? And the answer is yes, we do. So let's just have a look at this. Let's just write down 4 points. Okay. P1, P2, P3, P4, and like this. Good. So these are our 4 points. Now we have 2 lines, right? Let's just remember that. So there's line 1 and there is line 2. Okay. Now let's try to figure out where these lines are at. Okay. And as I said already, we can maybe prove that it doesn't matter how long x is. So for this first case, let's just assume that x is equal to 2. Okay, let's for this first case assume x is equal to 2. So this length is 2, and you have here a point at 0, 0, right? So this is basically very easy. Remember, always first the x, then the y. So in this case, it will be 2 and 5, right? 2 and 5. Next one, P3 and P4. We don't need any more points on this line because it's fully defined. Linear equation defined by 2 points. 2 points, fully defined, okay? Let's just say this is F1, and let's just say that this is F2. Do the same for the other one. 0, because it's exact on the y-axis, 8 up, 0, 8. Easy, very simple. And then you go 2 over, and then 0 up. So it's basically just 2 and 0. Great. Now, what are we doing with this? How is this helping us? Well, we've defined 4 points. We've assumed a variable. What are we even doing at this point? Let's see. You guys can tell me what the equation for a linear, or the standard equation for a linear equation is. So we have f of x is k times x plus d, right? This is basically just saying you have some variable, which is the incline decline. I've made a video on that already. Incline decline times x plus d, which is just some variable. And what is d? D is the intersection point of a line. So in this case, d is equal to 8. And in this case, d is equal to 0 because it's 0, 0, right? So we can tell that straight away. Good, great. Now that we have this, we should just be able to work this out actually fairly nicely, and this is going to go fairly fast, right? Now, in your head, guys, what is k? What is k defined as? K is incline decline, but what is the actual definition of this? Well, k is delta y over delta x. And if we plug this in, what is a delta? A delta is a difference from one to another. And also another thing for you guys, if you are doing these types of things, always look at the obvious things, right? One obvious thing is that this has a positive incline, or a positive, basically it's just going up, so it's positive. And this k must be negative because it's going down, right? So you already know, okay, from this function 1, let's just function 1 and function 2. Of this function 1, it must be positive because it's going up. So that means that this k must be positive. Okay, delta y. What is our delta y? We have 0, 5. So that means 5 minus 0 over 2 minus 0. Easy peasy, lemon squeezy. There we go. All right. 5 minus 0, 2 is just the same as 2.5. That is fairly easy. Great. Next one. Now, k. We said k1, k2. We said that this must be negative. Let's have a look. Is that true? Or am I just capping with y'all? Good. So, this was positive. And what did we actually do here? This was y2 minus y1 over x2 minus x1, right? 1, 1, 2, 2, and there you go. Same thing here. You have 2 minus 1, 0 minus, oh, that is the negative. Crazy. And now we just have 2 minus 0, which is the same as 4, right? I basically just, oh, sorry about that, minus 4, of course. Great, minus 4. 2.5 and minus 4. K1 is this, K2 is this. So now what we're gonna do is we're just gonna plop these values into a function and say that f1 of x is equal to k1, which is 2.5, times x plus, and where does this intersect the y-axis? at 0, right? So this is just basically plus 0, which means that we can actually leave this out entirely. Good. Next one. f2 is equal to, of x, of course, right? -4. And then x, and then plus 8. Good. And another, just a plausibility check, is -4x. What does it say? Again, delta y over delta x. It means that for one step to the right, we have to go 4 steps down. Does that make sense? Yes, because we're going 2 steps to the right, so we have to go 8 steps down, right? And this is exactly our 2 points that we have defined before. Great. And all that is remaining to do to actually solve, at least we think we solve it, but let's see if we really solved it, right? So all that's remaining to do is to say f1 is equal to f2. What is this saying? This is saying you're searching for a point where both of these values, x and y values, are the same. Where is that the case? Of course, in the point P. Let's do it. 2.5x is equal, and you just say is equals this. Simple, simple, simple. -4x plus 8. Now, of course, plus 4x, and then you have x is equal to 8 over 6.5, right? This is, of course, I throw this over and then just divide it by 6.5 on both sides, so we get this expression. Now, you might say, okay, this is the answer, 6.5, I'm done. Incorrect, because what is this saying? What is this telling us? This is telling us that at the distance, 8 over 6.5 from the left side lies our point. And now how do we figure out what this point is? Well, we already know the equations for the curve, right? We know that this applies and this also applies. So all we gotta do is just plug it in somewhere. Easy. Let's do that. f1 of x equals 2.5x. Simple, right? 2.5x times 8 over 6.5. And if I remember correctly, and you plug this into the calculator, it comes out as 3.076. Let's just say this is meters, okay? Good. And here you have it. Here is an answer, 3.076. Is this true even? Or is it for 1, is it 1.5 something? For 4, it's, I don't know, like 6 point something? We don't know. But how can we prove it? Well, we can prove it by testing other values, right? So let's go ahead and do that. So let's just delete this. Let's keep in mind that it's 3.076. Let's delete, I guess this. Let's delete all of this. All right, and here we go again. So let's just assume now for the second case, case 2, that x is equal to, and pick any number. I mean, pick any number, right? X is equal to, let's take 7, because 7, you know, is such an odd number. It's crazy. Anyways, prime number, by the way, as I'm sure you guys know. So let's do the same thing as before. And maybe you guys might have noticed a pattern here in this. The only place where we actually get to see our number that we've chosen is here and here, right? The only twos in these 8 numbers are here and here. What does that mean? Well, following simple logic, it means that we can just take these values and switch the 2's for a 7, right? So you get P1 is 0, 0. P2 is 7, 5. P3 is, sorry about that, P3 is 0, 8. And P4 is the same as 7, 0. I'm just checking if my camera is not overheating, because I've had this issue before many times and it was extremely annoying. Okay, 4 points, 2 per equation, easy done now. Let's do the same thing as before. K1 is equal to, K2 is equal to. Let's see. Okay, so we have 7 and 5. Let's remember delta y over delta x. Delta y is 5 and delta x is 7. K is 5 over 7. Simple, simple. Again, K2 must be negative because we're going down. So, same thing. We go from 0 to 8. So we have again minus 0. I mean, we have to leave this one out because if I had put the minus here and minus is plus. So we have to leave that one out. Good. 0 minus 8. And then you have 7 minus 0. Easy. Now, for the guys that don't know what I'm doing right here. This is the x value. And this is the y value, and the same is for this one, okay? And this k is defined by k is equal to delta y over delta x. And delta, in this case, means, I even wrote it here actually, I don't have to write it again. Delta y is the same as y2 minus y1, and x delta x is the same as x2 minus x1. So that's basically what it is here, okay? And then, what you're getting is minus 8 over 7. Great. 5 over 7 minus 8 over 7? Well, maybe. Maybe we're gonna get the same answer, maybe not. I don't know that we are, but let's just do it. Okay, so minus 5 over 7. So we have, can I actually do that straight away maybe for you guys so that I can save a bit of time and you can also save a bit of time? So let's just say F1. Let's just say maybe F3 and F4, okay? Because it's not F1 anymore. So I will define F3 as this line, but with this being 4, okay? So F3 is equal to F4, and of course, obviously, I don't know which one I said, but the other line that I just said is F4, right? So we just plug this in now. We say 5 over 7, and remember, we have nothing additional here, right? Let's just say that this is F3, right? With this being 4, because then we can say, okay, there is no D, right? So it is just 5 over 7 plus 0. Let me still put that there for you guys to make that a little bit more clear. And then we have minus 8 over 7 plus 8. Good. And now we simplify, simple math, plus 8 over 7. We get 13 over 7. Is that right? We just say, okay, the denominator is the same. Sorry about that. X, and then is equal to 8. And then we just say times 7 over 13. I also made a video on how to solve these types of simple equations. Very simple. Not a problem there at all. Okay, and now we've done this. We just multiply it by the inverse so that this and this cancels out. So we 7 cancel out, 13 cancel out. X is equal to 7 times 8 over 13. And you guys know that this is 56 over 13. Great. And now, if we went ahead and said, okay, we have, let's just say f2 of x, right, is minus 8 over 7 times x plus 8. This, oh, sorry about that, f4 of x. f4 of x is just this, right? We said this is f4 of x and this is f3 of x, right? This is this going down, but with this being 4. Okay, let me just 2 or 4, like that. Let's do it like that. And if I were to go ahead and plug for this x, 56 over 13, what do you guys think is gonna come out? Well, I know what's gonna come out. It's gonna be 3.0 something, right? So, so let's just put it down here maybe. F4 of 56 over 13 is minus 8 over 7 times 56 over 13 plus 8. Good. And here we go. Let me just pull up my calculator for you guys, because I'm not sure if this is correct. Guys, back at it. Look at that. Is the focus focusing? Oh, there we go. 3.076. That's it. We got it. We did. So, but I would like to add to this, although we have solved the problem, and we can actually now say h is equal to 3.076 meters. Although you have solved the problem, it still begs the question, is it correct? is this answer, although we got plugging in two different numbers, is it correct? Well, how do you know, or let me argue differently. How do you know that it doesn't change when we plug in 2,000, 3,000, a million, 2 million? How do you know that it doesn't change? Well, for that, I'm gonna make another video. But what I can say is that whenever you have something like this, and you have no value here, you just have to assume, okay, something must be, not off necessarily, but something must be for me to figure out. And we did figure it out. And we just got the same answer by plugging in 2 and I'm sorry about that. That is actually entirely wrong. This is of course not 4, but this is 7. Excuse me. 7. I don't know where that 4 came from. Anyways. So we have 2 and 7. We've tried it. You know, it seems like those are two different numbers, but let's just say maybe for 5 it doesn't apply, for 4.5 for the middle it doesn't apply. Well, as I said, that's for another video. But what I'm trying to teach you guys here, if you try this out and you get 2 of the same results, you can basically be sure that this applies for any number. Because I tried it for, I think in the morning I tried it for 5, and I tried for 2, 3, I think, and 5. And for 3 it worked, and for 5 it also worked. So if it works for these numbers, you can actually be sure that is correct, right? And or that applies for any case. And also something to keep in mind, we've just proven, or not really proven yet, because this is just math, right? To prove something we need to have variables. But we have basically said that it does not matter which length you plug in here, it's always going to be 3.076 meters. That is very nice, I think. And something that, yeah, just I think gets you to think how nice it is that you can have 2 random triangles and this height is not going to change no matter how long this is, right? All right, guys, I want to thank you very much for watching today. I hope this was a fun one. My camera did not overheat. I got a new one. I mean, yeah, it doesn't matter. And I wish you a wonderful day. Do this for yourselves. If you do this for yourselves, it's gonna stay in your brain way better. This is scientifically proven. You can ask or look it up. If you do something right after you've seen it or while you're watching it, it is like, I don't know, probably 100% more likely. I don't know. Don't take these numbers for don't take these numbers for granted, but something like that. More likely that you remember this. Thank you and have a great day, and I'll see you in the next one. Goodbye.